Welcome to the world of Dreamside Traveler. Here, beneath the soothing sound of gentle rain, we journey through time and space, uncovering the mysteries of the past and diving into the most captivating pages of human history. This place is created for those who love exploring the world in the quiet of evening, for those who value peace while yearning to discover something new before sleep. If you enjoy what you're hearing, please give this video a like. It helps other people find our stories. Help us reach our first 1,000 subscribers in our club of nighttime history lovers. And the Dreamside Traveler channel will become your faithful guide to sleep. We're constantly adding new stories for your peaceful evenings. And if you have ideas about which historical topics interest you, or simply want to share your thoughts, leave comments below the video. I'm genuinely curious to know what inspires you. Now close your eyes. Feel this gentle rain outside your window. Allow yourself to relax. Our journey begins right now. It is the heart of our celestial garden. Long before there were planets, moons, oceans, or even words and poetry, there was light. That's how it all began. Roughly 4,600,000,000 years ago, in a quiet corner of our galaxy, the Milky Way, a cold, dark cloud of gas and dust floated in peace. It didn't seek fame, didn't chase dreams. It simply waited. And then, a ripple. A faint touch like a breath of wind on a still lake. Perhaps it was the shockwave of a nearby exploding star, what scientists call a supernova. That wave passed through the cloud and changed everything. Gravity, the silent sculptor of the cosmos, began its work. Slowly, it pulled the gas and dust inward, coiling them into a spinning, tightening core. This dense knot of matter began to heat up, and then it caught fire. That core became our sun, the furnace where hydrogen turned into dreams. As more matter collapsed inward, pressure soared. The temperature at its core rose to an unimaginable 15 million degrees Celsius. And then, something extraordinary happened. Hydrogen atoms began to fuse, forming helium and releasing colossal amounts of energy in the process. Nuclear fusion had begun. Light was born. The sun awoke. To the eye, it may seem like a gentle golden yolk in the sky. But don't be deceived. This is no quiet breakfast egg. It's a colossal, furious sphere of plasma, over 1,400,000 kilometers wide. That's like placing 109 Earths side by side. Its mass, it accounts for more than 99.8% of the entire solar system. All the rest, Jupiter, Saturn, Earth, coffee cups, music, cats, makes up just the remaining fraction. Deep inside, billions of hydrogen atoms collide every second. They fuse into helium, releasing energy in the form of gamma rays. This energy begins a slow journey outward, passing through layer after layer of the solar interior. Though it takes light just 8 minutes and 20 seconds to reach your face from the sun's surface, it spends thousands of years making its way from the core to that surface. The sunlight warming your cheeks today may have started its journey before humanity learned to write. The sun is a balance of mighty forces, gravity pulling in and fusion pushing out. A glowing tension that holds for billions of years. Its composition, mostly hydrogen, about 74%, then helium, around 24%. The rest is a trace cocktail of elements: oxygen, carbon, neon, nitrogen, magnesium, iron, silicon, what you might call the party crowd of the periodic table. These elements swirl in different zones. The core, where fusion happens. The radiative zone, where energy drifts slowly outward. And the convective zone, where hot plasma bubbles and churns like a boiling soup. Above all that lies the photosphere, the blazing surface we see, with a temperature of about 5,500 degrees Celsius. But the real cosmic drama lies further out. The chromosphere and the corona. The corona is so bizarrely hot, millions of degrees, that it still puzzles scientists. How can the outer atmosphere be hotter than the surface? The sun doesn't explain. It prefers mystery. It also has moods, dark sunspots, fiery flares, storms that twist space itself. Its magnetic field sometimes lashes out with tremendous force. Giant loops of plasma, called prominences, dance across the sun's surface. Occasionally, the sun hurls massive clouds of charged particles into space, coronal mass ejections. These can disrupt satellites, GPS signals, even power grids. But they also gift us with auroras, those ethereal curtains of light near the poles. Beauty and chaos, side by side. And there is something almost hypnotic about the sun. Its swirling plasma, its constant pulse, its endless churning, as if it were breathing. Imagine standing on a distant world, orbiting a star like our own. That star would bathe your skies in fire and gold, day after day, for millions of years. Ancient humans looked up at the sun and gave it names, legends, divinity. In Egypt, it was Ra sailing his golden boat. To the Greeks, Helios or Apollo. To the Aztecs, Tanatia. In Japan, Amaterasu. It brought crops, told time, guided rituals, commanded the solstice. People built monuments like Stonehenge to honor its rhythm. Even sunflowers bow to its light. And though our love for the sun is poetic, romantic, mythic, the sun never notices. It just burns, blissfully unaware, needing nothing. Now lean in close, here's the twist. The sun is not eternal. Like all stars, it had a beginning, and it will have an end. We're living in its middle age, the main sequence. It's been stable for about 4.5 billion years, and will remain so for about 5 billion more. But when the hydrogen in its core begins to run out, the sun will bloat. It will swell into a red giant, likely engulfing Mercury, Venus, and yes, Earth. But don't panic, we have time. Billions of years of time. Enough for empires to rise and fall, for humans to visit Titan, to build cities on Mars. After that phase, it will cast off its outer layers in a glowing farewell, a planetary nebula. What remains will be a white dwarf, a tiny ember of what was once a star. That white dwarf will cool slowly, millions of years, then billions, until eventually it becomes a black dwarf, a cosmic ghost, adrift in the silence of space. But this isn't a sad ending. It's a return. The elements the sun releases will enrich the universe. One day, they may form new stars, new worlds, new dreamers. But for now, it's here. Alive, radiant, warming the earth. Every tan line, every rainbow, every blade of grass that photosynthesizes, every firefly's spark. It all traces back to that ball of light, 150 million kilometers away. The sun is the clock of life, the heartbeat of the solar system, a cosmic lighthouse, and it asks for nothing. So next time you squint at the sky and say it's too bright, remember, you're looking at a star, your star, a 4.5 billion-year-old engine of light, burning not for you, but burning anyway. And here we are, grateful passengers in its orbit, dancing through space in an endless planetary waltz, round and round in awe. Mercury stretched its slender golden arms across the sky of Earth, a quiet shimmer brushing the edge of morning or twilight. Long before you rose from sleep or blinked into the fading light, Mercury had already twirled around the sun, quick and light-footed, like a playful child chasing sparks in the dark. It's the smallest planet in our solar family, the one closest to our brilliant star. It doesn't shout with thunderous storms or parade icy rings. It doesn't cradle oceans or wear gowns of swirling clouds. And yet, dear dreamer, it holds a magic all its own, a silent, ancient kind of wonder. The magic of stillness, the magic of survival, the beauty of a world forged in fire and silence. About 4.5 billion years ago, Mercury was born from the same great swirling cloud of dust and gas that gave birth to our sun, the planets, and countless other celestial wonders. But something unusual happened during its making. Maybe it was crafted under different conditions, or maybe it was scarred early by massive cosmic collisions, because Mercury is different. It's tiny, just a little bigger than our moon. But deep beneath its battered rocky skin lies a secret, a giant iron-rich core. That heavy heart makes up more than 60% of the planet's entire mass. That's more core than crust. It's as if Mercury was meant to be grander, more expansive, but somehow lost its outer layers in a violent, ancient accident. Or maybe, just maybe, it was always meant to be this way. A little giant, a heavyweight wrapped in a featherweight body. Despite being so close to the sun, Mercury isn't the hottest planet in our solar system. That title belongs to Venus, queen of greenhouse gases. But Mercury, oh, Mercury, experiences the most dramatic temperature swings of any planet we know. When the sun shines down, its surface can reach temperatures as high as 430 degrees Celsius. That's 806 degrees Fahrenheit, hot enough to melt lead. But when night falls, the temperature plunges to minus 180 degrees Celsius, or around minus 290 degrees Fahrenheit. It's like a cosmic furnace that suddenly becomes a frozen cave. A place where fire and ice live just a breath apart. If you look closely at Mercury's skin, dear listener, you'll see the echoes of time. Its surface is a patchwork of ancient scars, wearing the stories of billions of years like an old sage wearing its age with grace. There are craters, countless ones, and great plains of frozen lava, ridges that stretch across the landscape like wrinkles on the face of an immortal storyteller. One of Mercury's most dramatic features is the Caloris Basin, an enormous impact crater more than 1,500 kilometers wide. When the massive object slammed into Mercury to carve this giant scar, the shockwaves traveled all the way through the planet. On the opposite side of the globe, it left behind a jumbled region of hilly, broken terrain, as if Mercury itself shuddered and froze in pain. A planetary concussion, frozen forever in stone. Mercury is also shrinking. Yes, shrinking. As it slowly cools over billions of years, its surface contracts, forming towering cliffs that soar up to 1 kilometer high and stretch for hundreds of kilometers. Imagine a world growing smaller with age, curling inwards like an apple left in the winter air. A rocky planet folding into itself like a memory trying not to fade. Time on Mercury doesn't flow the way it does here on Earth. It moves with a curious rhythm. Mercury zips around the Sun in just 88 Earth days, faster than any other planet. But it spins slowly, very slowly. From one sunrise to the next, a single day on Mercury lasts about 176 Earth days. Can you imagine that? If you stood on Mercury's rocky skin, wearing a very sturdy spacesuit, of course, you'd see the sun rise slowly above the horizon, pause strangely in the sky, move backwards toward where it came from, pause again, and then continue forward to finally set in the opposite direction. A surreal dance of light and shadow. On Mercury, day and night are not just passing times, they are celestial events. But Mercury doesn't have much of an atmosphere. No fluffy clouds to hide in. No winds to whisper secrets. Instead, it has a ghost-like halo of scattered atoms, blown off the surface by solar winds and tiny space rocks. Scientists call it an exosphere, not thick enough to be a true atmosphere, but still something. A breathless whisper, clinging to a silent world. And yet, despite this, Mercury has a magnetic field. Faint, but real. That means the little planet is still alive inside, at least partly. Its enormous iron core is likely still molten, still moving, still humming with energy after billions of years. Imagine that. A tiny planet with a glowing iron heart, pulsing in the deep black of space. We only truly met Mercury because of 2 brave space missions. The first was Mariner 10, which flew by in the 1970s and gave us our first up-close glimpse of this elusive world. Then, decades later, came Messenger, launched in the early 2000s. It orbited Mercury, mapped its surface, and revealed breathtaking details never seen before. And now there's another journey underway. A joint mission by Europe and Japan, named Colombo, is traveling through space right now. It will arrive at Mercury in the 2030s to continue the story, to listen to the planet's quiet heart and learn what secrets remain. Mercury was named after the Roman god of messengers and speed. How fitting, don't you think? A planet that loops endlessly around the sun like a whisper circling the flame. Mercury has no moons, no rings, no noise. It is utterly, perfectly alone. But still, it glows. If you know where to look just after sunset or before sunrise, you might catch a glimpse of it. A silver dot near the horizon. The morning star, the evening wanderer. It never strays far from the sun, never lingers long. It's always just out of reach. a flicker, a breath. In its quietness, Mercury teaches us something rare. Not everything needs to roar to be powerful. Not every story must be loud to matter. Some stories, like Mercury's, are written in scars and silence. Some are whispered in shadow. Some shine quietly at the edge of our sight, asking only to be seen. So rest now, dear dreamer, and carry Mercury close to your heart, the shy, silver traveler with a core of fire and a skin of memory. Let its quiet strength guide you through the night. Good night, dear soul. We float onward, silent and slow, through drifting stardust and warm golden mist, toward a beacon in the sky, the second planet from the sun. She shines so brightly that even the stars seem to dim in her presence. So luminous, so enchanting, she was named for the Roman goddess of love. But don't be deceived by her gentle glow. Venus may dazzle, but she does not embrace. She burns, she blinds. She keeps her fury hidden behind a shimmering veil. Yes, Venus is radiant, but under that soft, blushing light lies a storm-tossed, volcanic world. She may be Earth's twin in size and gravity, but her temperament is wildly different, a sister forged not of water and wind, but of sulfur and fire. A dangerous sister, a warning in the form of a planet. If you've ever looked up at the edge of night, just after sunset or before dawn, and spotted a fierce white light low on the horizon, brighter than any star, then you've seen her. Venus, the morning star, the evening star. After the sun and the moon, she is the brightest object in our sky. She has inspired lovers, wanderers, and poets for thousands of years. The ancient Babylonians knew her as Ishtar, goddess of love and war. The Mayans carefully tracked her path, weaving her into their calendar. To the Greeks and Romans, she was divine beauty incarnate. Her light once guided ancient sailors across unknown seas. Now it lures scientists deeper into cosmic mysteries. And yet, for all her shimmer, Venus is an enigma. Her true face is hidden beneath a suffocating cloak of clouds, thick layers of carbon dioxide and droplets of sulfuric acid. No telescope on Earth can see through it. Only radar and a few brave machines have managed to glimpse the world beneath. Imagine standing on Venus, but please don't. The surface temperature there is over 460 degrees Celsius. That's around 860 degrees Fahrenheit. Even though Venus is farther from the sun than Mercury, it's much, much hotter. Why? Because of her atmosphere. Venus is the solar system's ultimate example of what a runaway greenhouse effect can do. Her carbon dioxide, rich atmosphere traps heat so effectively that the temperature never changes. Day or night, pole or equator, she is a furnace all the time. Above the molten ground, hurricane-force winds scream through the upper sky at more than 350 kilometers per hour. The clouds churn with acid, not water. The air is unbreathable. The pressure on the surface is 92 times that of Earth's. That's like being crushed beneath the weight of a full kilometer of ocean. And yet, despite it all, she is stunning. The sky glows orange, bathed in refracted light. The horizon curves dramatically, as if you're looking at the edge of a dream. Endless plains of cooled lava stretch in every direction, broken only by the scars of ancient eruptions. Massive dome-shaped volcanoes rise from the surface, like sleeping giants under heavy mist. Venus is alive, maybe not with life, but with geological fire. In fact, she has more volcanoes than any other planet we know. Possibly over 1,600. Most are dormant. Some may be erupting even now, far beneath the clouds, hidden from our instruments. She has strange, pancake-shaped domes, vast lava fields, and immense ridges that crisscross the terrain. Her surface appears young in geological terms, suggesting she might erase her past now, and then by resurfacing herself in molten stone. Unlike Earth, Venus has no tectonic plates. Her crust does not crack into continents, but she still shifts. She quakes. She flexes. Her surface ripples under slow, silent pressure, a kind of tortured grace, geologically speaking. Only a few machines have ever touched Venus, and none survived for long. In the 1970s and 80s, the Soviet Union's Venera missions managed to land several probes. Most of them lasted mere minutes, but they sent back precious photos, yellow, cracked rocks under a golden-orange sky, blurred by heat, pressure, and time. Later missions, like NASA's Magellan, used radar to map the surface in detail. What they found was a planet scarred by fire and sculpted by forces we still don't fully understand. And the questions remain. Could Venus once have been Earth-like? Did it ever have oceans, lakes, or a gentle rain that fell from soft skies? Many scientists believe it did. Billions of years ago, Venus may have been a mild, temperate world, but something changed. The sun's energy, combined with Venus's atmosphere, triggered a cascade of heat. Water, if it ever existed, boiled away. The greenhouse effect accelerated. Clouds thickened. The planet transformed into the inferno we see today. But what if, just what if, life once found a way? Could microbial life have floated in her upper clouds before the heat came? Could chemical hints in today's atmosphere be ghostly traces of something that once lived? We don't know. Not yet. Venus does not give up her secrets easily. More missions are coming. NASA is planning new ventures. So is the European Space Agency. Instruments are being prepared to dive once more through her clouds to seek answers hidden beneath her toxic skies. Not because we dream of living there, acid rain is no paradise, but because understanding Venus means understanding ourselves. Our climate, our future, our place in the story of planets. And still, through all this, she remains what she has always been. The first light in the dark, the last gleam before morning. She is beauty wrapped in danger, flame hidden behind gold. So rest, traveler. Let your thoughts drift across the heavens and let Venus shine within you. She is ancient, unforgiving, and breathtaking. A goddess no longer worshipped, but never forgotten, her kiss still warm in the imagination of Earth. Not just a planet, a miracle suspended in darkness. While stars burn and galaxies spin in silence, Earth glows with a quiet, defiant light. It is the luminous cradle of life. And instead of racing away into the black unknown, let's turn our gaze homeward to the familiar, the miraculous. This is the only place we know where the morning begins with birdsong, where the oceans rise and fall in a rhythm older than memory, and where something as sweet as a strawberry grows from the soil. Earth, our third stone from the sun, not the brightest, not the biggest, but the most alive. We forget her too often. We walk her skin and drink her waters, yet rarely pause to wonder. Venus gleams, Mars broods, but Earth breathes. She flourishes. She dares to cradle life in ways no other world has managed. So come closer, dreamer. Let yourself fall in love again. From space, Earth steals the breath, a sapphire marble cloaked in flowing white veils. Her oceans shimmer like glass, her continents drift like ancient puzzle pieces slowly shifting over eons. Thunderstorms swirl with silent drama, and her ice caps sparkle like crystal crowns. Sunlight dances along the atmosphere in emerald and violet ribbons. Auroras that pulse like music we can't quite hear. But Earth is not just geologically alive, though yes, she quakes, erupts, and reshapes herself. She is biologically, ecologically, emotionally alive. From the crushing depths of the ocean trench to the whispering meadows high in the clouds, life breathes. Life crawls, leaps, blossoms. Life endures. Water flows freely here, not trapped as ice beneath a shell, not bound to vapor, but alive. It carves canyons, kisses roots, hums through rivers and taps gently on rooftops as rain. It floats in clouds and freezes on mountaintops. Earth speaks through water, her softest and strongest voice. And beneath her crust, a molten heart spins. A churning, iron-rich core, the source of our magnetic shield. It protects us from the fierce solar winds. It creates new land. It glows and bubbles up in volcanoes that remind us Earth is not still, never still. This world is balance in motion. Fire and ice, storm and calm, death and bloom. Against all odds, life not only survives here, it thrives. Her atmosphere is rare perfection. 78% nitrogen, 21% oxygen, just enough carbon dioxide and argon to carry sound, cradle clouds, and keep us warm without boiling us. Thin enough to see the stars, thick enough to hear music. This air carries laughter, carries thunder, carries words like this one. Mars offers too little air, Venus offers poison. But Earth offers breath. And again, the magnetosphere, the silent hero born from Earth's molten spin. It dances with solar storms and turns chaos into light shows near the poles. Gentle auroras swirl in curtains of green, violet, and rose. No sound, just wonder. Even Earth's skin is restless. Her continents drift slowly, silently. Tectonic plates shift, shaping mountains and valleys, giving rise to islands and rifts. These movements bring quakes and fire, yes, but they also bring change. They recycle carbon, stir the oceans, birth new ecosystems. Without them, life would stagnate. And then there is the moon, Earth's loyal companion. Only one, but mighty. She steadies our tilt, draws tides across the shore, and paints our night sky in silver. Her gravity choreographs the rhythms of coral reefs, bird migrations, and even our sleep. Every day, Earth spins once, a graceful pirouette giving us day and night. Every year, she dances around the sun, tilting just enough to give us seasons. Winters hush, springs bloom, summers blaze, and autumns glow. In all the cosmos, We've seen no other world that does this. No other planet holds forests that stretch across thousands of kilometers. No other planet has coral reefs intricate as lace, or birds that navigate with magnetic fields. No world we've found so far grows apples, hums with bees, or invents lullabies. And then there's us, humans, Homo sapiens, fragile, brilliant, and endlessly curious. From this soil came pyramids and paintings, symphonies and space stations. From this blue sphere rose Einstein's thoughts and ancient myths whispered over firelight. Every story you've ever known, it started here. Every song, every heartbreak, every poem. We are made of stardust, yes, but Earth gave us the voice to sing about it. She gave us the air to speak, the warmth to build, the land to grow. We dreamed of flying, and Earth gave us trees to climb and skies to soar. We searched the skies, rightly so, seeking other worlds, other chances. But so far, only Earth knows how to hold us. Only she has offered not just survival, but love. We've made homes on her mountaintops and beneath her seas. We've walked across her deserts, skied her glaciers, and flown above her clouds. We've made mistakes, many. But we are also capable of awe, of gratitude, of care. Earth is not infinite. Her climate shifts. Her resources stretch only so far. She has outlived fire and ice, comets and collisions. Now she waits to see what we do next. She doesn't ask for perfection, only kindness. Only that we notice. Only that we celebrate. So tonight, before your dreams drift toward alien skies and distant stars, pause. Lay your head down and remember the one world that gave you lullabies, languages, cocoa beans, and butterflies. Good night, dear dreamer, and thank you, Earth, for everything. Our moon, the silent guardian we've always gazed at through our windows, from our beaches, from our beds, is more than just a rock in the sky. It's the force that pulls at the oceans and the human heart alike, a steady companion that has never left us. This quiet satellite has shaped Earth's story from the very start. Lie back, dear dreamer, and let moonlight softly drift across your thoughts. Her tale began long before ours, over 4.5 billion years ago. Shortly after Earth itself was born, a colossal object the size of Mars, known as Theia, collided with our young planet in an unimaginably fierce impact. The Earth was shaken, oceans of molten rock roiled, and clouds of debris filled space. But from this chaos, something extraordinary was born. Pieces of Earth and Theia were hurled into orbit, swirling in a glowing halo of molten rock. Over time, gravity gathered these fragments together, forming a sphere. As it cooled and hardened, it began its eternal dance around Earth. The moon was born. The moon wasn't caught or found. It was forged in the same fiery birth that shaped our home. She is Earth's daughter, sister, and lifelong companion, never straying far. Though small, just over a quarter the diameter of Earth, her presence is mighty. Her surface is mostly rocky, covered in fine dust and powdered stone called regolith. No seas, no rivers, no air, yet breathtakingly beautiful. Dark plains called Maria, Latin for seas, stretch across her face, ancient lava flows hardened long ago. Her skin is pocked with craters, scars from billions of years of cosmic collisions. Mountains rise, valleys sink, and beneath it all lies a small iron core, a whisper from her molten past. Without atmosphere, there is no sound, no weather, no erosion. The moon remembers everything, every impact, every scar. Despite her silence, the moon moves Earth every day. Her gravity pulls the oceans into bulges we call tides. As Earth spins, these bulges shift, creating the rhythm of high and low tides twice daily. It's an ancient lunar song that guides the water's dance. The sun adds its own pull, and when sun and moon align, we see spring tides with higher highs and lower lows. When they stand at right angles, neap tides bring calmer seas. But it's not just the oceans the moon stirs. Studies suggest she influences our sleep patterns, especially during the new moon, when her face hides in darkness, or the full moon, when she lights the sky like a glowing lantern. Some people experience restless nights, vivid dreams, or stronger emotions. Science debates the cause, circadian rhythms, gravity, ancient instincts, but the moon's reach extends beyond water. She touches our moods, our myths, and our minds. From Earth, we watch the moon wax and wane, cycling through phases every 29.5 days. The lunar month begins with the new moon, invisible in the dark sky, a quiet start. Then the waxing crescent grows, a silver sliver emerging. The first quarter shows half the moonlit, half shadowed, perfectly balanced. Waxing gibbous nears fullness, almost there. The full moon shines bright and bold, whole and radiant. Waning gibbous fades slowly, followed by the last quarter, half again but retreating. Finally, the waning crescent whispers goodbye before she disappears again. The moon doesn't change shape. It's our perspective and the sun's light that create this dance of shadows. These phases have guided human life for millennia, shaping calendars, harvests, celebrations, and rituals. They are the moon's poetry, written in arcs and curves across the night sky. Sometimes the moon and sun align perfectly with Earth, and something magical happens. A solar eclipse occurs when the moon slips between Earth and the sun, casting a shadow that darkens day into an eerie twilight. Birds hush, temperatures drop, and crowds hold their breath, gazing upward in awe. A lunar eclipse happens when Earth's shadow falls on the moon, turning it a deep rusty red, a blood moon. These eclipses, occurring during full moons, can last for hours, painting the sky with ancient drama. Eclipses are rare, precise, and fleeting. Reminders that even the grandest cosmic bodies cast shadows, and that darkness itself can be beautiful. On July 20th, 1969, humanity did the unimaginable. Apollo 11 touched down on the moon, and astronaut Neil Armstrong took the first step onto its dusty surface, saying those famous words, "One small step for man, one giant leap for mankind." It was a moment that wove together science, courage, and dreams. For the first time, Earth's child met her parent. Since then, 12 astronauts have walked on the moon, leaving footprints that may endure for millions of years. They returned with rocks, stories, and a humbling awareness of how fragile and beautiful our pale blue dot truly is. Today, we prepare to return with new missions and fresh dreams. the moon's story is far from over. She has watched every human life that ever existed, lovers whispering, wolves howling, poets sighing, tides rolling in. She has been worshipped, studied, feared, and longed for. The moon shapes our calendars, our languages, our lullabies. Her pull is not just physical, it's emotional, existential. And she is still watching, always the same face turned towards us, tidally locked in perfect devotion, a cosmic constant, a quiet companion. So rest now, dear dreamer. Let the moonlight wash over you. Let her phases guide your breath. Let her story remind you that in the dark, we are never truly alone. There is always light, always rhythm, always a silver smile shining in the sky. Tomorrow, we cross a quiet gulf of space, passing our silver guardian, Earth's moon, and step into the cold, rust-colored arms of Mars. This world has held our fascination ever since humans first lifted their eyes to the night sky. A tiny red dot drifting silently among countless stars. To ancient civilizations, it was the god of war. To scientists, a puzzle wrapped in dust. And to dreamers like us, it is pure possibility, a whisper of maybe one day. Come, dear dreamer, let's explore this crimson wanderer together. Mars is the fourth planet from the Sun, a little more than half the size of Earth, with a diameter close to 7,000 kilometers. It's a rocky world, dry and cold, covered in iron oxide, which is just a fancy name for rust. That rust paints Mars with its unmistakable reddish hue, like a planet made of forgotten memories and powdered sunsets. Unlike Earth's blue skies, the Martian sky shifts colors, soft butterscotch and peach during the day, turning to gentle blues at sunset. It's as if Mars wanted to keep its skies poetic, but in reverse. Its days last just a bit longer than ours, about 24 hours and 39 minutes, and thanks to its tilted axis, Mars also experiences seasons. But these seasons are colder, much colder. Even near the equator, summer temperatures rarely climb above freezing, though they can reach a mild 70 degrees Fahrenheit, or about 20 Celsius. In winter, temperatures can plunge to nearly minus 225 degrees Fahrenheit, about minus 153 Celsius. Mars is a world that feels familiar, but lonely. The terrain is epic. Towering mountains, jagged cliffs, endless valleys, frozen dunes, and whispering plains stretch as far as the eye can see. Start with Olympus Mons, the largest volcano in the entire solar system. It soars nearly 22 kilometers high, 3 times taller than Earth's Mount Everest, and sprawls across 600 kilometers, big enough to cover the whole state of New Mexico. Imagine a mountain so vast it curves with the planet itself. Then there's Valles Marineris, a canyon system that would stretch across the entire United States. It plunges as deep as 7 kilometers and stretches 4,000 kilometers long, a massive scar carved by ancient forces. Mars is a frozen storyteller. Its surface is inked with tales of cosmic violence, flowing lava, ancient water, and relentless dust storms. Some craters date back billions of years. Others are relatively fresh, created by more recent meteor strikes. The landscape is like a frozen library of time, its pages turned by winds and storms. Once Mars held water, not just frost or ice, but rivers, lakes, maybe even oceans. Today, dry riverbeds wind across its surface like veins carved in stone. Satellite images reveal ancient deltas, floodplains, and channels carved by flowing water. The polar ice caps, made of frozen carbon dioxide and water, grow and shrink with the seasons. But where did all that water go? Mars lost most of its atmosphere long ago, likely because the solar wind stripped it away when the planet's magnetic field collapsed. Without that protective shield, the water evaporated or froze, leaving only traces behind, a lost paradise, a thirst never quenched. Yet hope remains beneath the surface. In 2018, radar readings suggested a hidden, salty lake beneath Mars's southern polar ice cap. Could life be hiding there in secret, microbial, and patient? Mars doesn't shout, it whispers. And if we listen closely, maybe it will whisper back. Mars has never been truly alone. For decades, robotic explorers, curious, tireless, and silent, have roamed its surface. The Viking landers were the first to touch down, followed by the Spirit and Opportunity rovers, dusty, determined pioneers. Then came Curiosity, a sky crane miracle delivering a mobile laboratory. Perseverance joined the quest, and even a tiny helicopter named Ingenuity has flown in Martian skies, a historic first for another planet. These missions have sniffed the soil, tasted the air, and drilled deep into rocks. They've searched for signs of life, ancient or present, studied the geology, weather, and atmosphere. Methane plumes and organic molecules hint at secrets still buried beneath the dust. The biggest question remains: could Mars ever have supported life? Could it do so again? The answer might not come from machines, but from people. Mars is more than a planet. It is a promise, a destination, a mirror. If Earth is our cradle, Mars could be our first true step into the cosmos. Scientists and engineers dream of habitats beneath the rusty sky, growing food in sealed greenhouses, harvesting water from underground ice. Rockets have already carried supplies and tests. Human footsteps may follow. It won't be easy. The cold, radiation, and isolation are fierce challenges. Mars is unforgiving, but not impossible. Imagine waking up beneath a salmon-colored sky, two tiny moons drifting overhead, watching the sun rise dimly over dusty hills. Planting the first seeds in Martian soil, writing a new chapter in humanity's story, one red stone at a time. Mars's two moons, Phobos and Deimos, named after fear and terror, are no cause for fright. They're small, rocky, and oddly shaped, no bigger than cities. They race across the sky like loyal shadows, watching over the silent planet below. Mars itself hums, not in sound, for it has little seismic activity, but in spirit. Winds whistle through canyons, dust devils dance across plains, and silence sings frequencies only dreamers can hear. Even now, Mars shapes us, our science, our stories, our sense of wonder. So close your eyes, dear dreamer. Let Mars cradle you in its rust-red arms. Listen to the echoes of ancient rivers and the soft buzz of rovers still exploring. One day you may walk there. For now, just dream. Now let us drift away from the cozy warmth of the inner planets and journey into the vast domain of giants, where the sunlight grows dim and shadows stretch endlessly across the cosmic depths. There, looming like a legend, stands Jupiter. This is no ordinary planet simply circling the sun. Jupiter reigns supreme, a colossal monarch sculpted from gas and gravity. It is a world so immense that it could engulf more than 1,300 Earths and still have space left for dessert. Yet behind this grand scale lies mystery, majesty, and a quiet strength that has shielded our tiny blue home from countless cosmic dangers. So, float with me now, dear dreamer, and let us greet Jupiter, the stormy guardian of our solar system. Jupiter is the fifth planet from the Sun and by far the largest. Its diameter stretches about 143,000 kilometers, making it 11 times wider than Earth. But size is only part of the story. What truly sets Jupiter apart is its makeup. It is a gas giant, a swirling orb of hydrogen and helium, more star-like than solid. It has no solid surface to stand on. If you were to fall into Jupiter, something I do not recommend, but imagine for a moment, you would sink through thousands of kilometers of thick atmosphere, crushed and baked by unbearable pressure and heat until you turned back into stardust. The planet's outer layers are clouds painted in sweeping bands of cream, rust, gold, and soft rose. These are actually jet streams, powerful bands of gas racing in opposite directions, creating storms that do not last days or weeks but centuries. Jupiter is not merely a planet. It is a living atmosphere in constant motion. Among these storms, one tower above all, the Great Red Spot. This gigantic swirling storm is wider than Earth itself and has raged for at least 350 years. New research suggests it might have formed around 190 years ago, which is younger than once thought. Yet, it remains the largest and longest-lived storm in our solar system. Imagine a hurricane on a planetary scale, with winds howling at more than 400 kilometers per hour. This storm shifts shape and color, but never ceases to rage. Why it glows red remains a mystery. It might be chemicals reacting with sunlight, or perhaps it is Jupiter's way of showing off. But the Great Red Spot is not alone. Smaller storms bubble and churn like boiling water, some merging, others fading, some lasting for years. At Jupiter's poles, spectacular auroras blaze, more powerful than those on Earth, shaped by a magnetic field 20,000 times stronger than our own. From far away, Jupiter pulses with raw energy, lightning flashing through dense clouds, magnetic fields twisting the very fabric of space. It is a stormscape like no other. Jupiter is not just a beautiful sight, it is vital. Its immense gravity acts as a cosmic vacuum cleaner, attracting or deflecting asteroids and comets that might otherwise collide with Earth. Scientists believe that in the early days of the solar system, Jupiter's pull helped shape the orbits of planets and kept the inner worlds relatively safe. Without Jupiter's presence, life on Earth might never have taken hold, or if it had, it may not have survived. So when we gaze upon Jupiter, we do not see just a giant ball of gas. We see a silent guardian, a protector watching over us for billions of years. But Jupiter does not travel alone. It commands a kingdom of at least 95 moons, each unique and telling its own story. Some are tiny, irregular moons, captured objects from the chaotic early solar system. Others belong to the famous group of 4 discovered by Galileo in 1610. The Galilean moons, each more fascinating than the last. Io, the most volcanically active body in the solar system, is a world of fire, constantly erupting with lava that paints its surface in bright yellows, reds, and whites. Europa is smooth and icy, but hides a vast ocean beneath its frozen shell, a possible haven for life, warmed by tidal forces in a world of water and whispered secrets. Ganymede is the largest moon in the solar system, even bigger than Mercury. It has its own magnetic field and hints of a subsurface ocean, a moon fit for giants. Callisto is ancient and cratered, its surface unchanged for billions of years, holding the memory of the solar system's violent youth, a world of time itself. These moons are not mere companions. They are worlds in their own right, and may hold answers to some of humanity's deepest questions. We have visited Jupiter many times through the eyes of Voyager, Galileo, Juno, and others. We have seen its lightning, measured its magnetic fields, flown past its moons. Yet Jupiter keeps many secrets. What lies deep beneath its thick clouds, hidden in a core made of solid rock, or perhaps a sea of exotic metallic hydrogen? Jupiter guards these mysteries closely, wrapped in layers of crushing pressure and swirling gas, as if to say, not yet, but the wonder lies in the waiting. Every orbit, every brush with its atmosphere brings us closer to understanding the forces that shaped not only our solar system, but perhaps countless others across the galaxy. Jupiter is both mystery and memory, promise and puzzle. It is the storm that birthed silence, the weight that brought balance. So rest now, dear dreamer. Let Jupiter cradle you in its vast arms. Listen to the whispers of wind through alien clouds. Watch the moons glide silently by. And remember that even in the deepest reaches of space, someone is always watching the skies. Now let us journey beyond the blazing sun and past the mighty orbit of Jupiter, venturing into a cold, quiet realm where light softens into gentle shadows that stretch endlessly, and beauty reveals itself in its grandest form. There, in the vast cosmic ballroom, spins Saturn, the 6th planet from our star, wearing its magnificent rings like a shimmering crown, twirling silently in elegant grace. It is a world so captivating, so poetic, that even the biting cold cannot steal away its charm. So close your eyes, dear dreamer, and drift with me as we meet the elegant enigma that is Saturn. Saturn is a gas giant, much like Jupiter, yet more delicate in nature. Though it claims the title of the 2nd largest planet in our solar system, measuring about 120,000 kilometers across, it is surprisingly the least dense. If you could find a bathtub vast enough for the cosmos, Saturn would float upon its surface. Its atmosphere is made mostly of hydrogen and helium, with mighty winds that can race at speeds exceeding 1,800 kilometers per hour. Yet, unlike Jupiter, Saturn is quieter, its cloud bands more subtle, its storms more secretive, hiding their power beneath serene veils. At the planet's northern pole spins a most mysterious shape, a perfect hexagon, a jet stream so vast and precise it defies simple explanation. This six-sided storm is larger than our entire Earth and has been swirling for decades, perhaps even centuries, a planetary snowflake drawn in clouds. Beneath those shimmering layers, Saturn's core may be composed of solid rock and ice, wrapped in a thick shell of metallic hydrogen, surrounded by swirling layers of gas. Though the planet keeps this secret well hidden, Saturn's rings are its crown jewels, stretching more than 280,000 kilometers from the planet, wide enough to fit 21 Earths side by side, yet astonishingly thin, only about 10 meters thick in most places. They spread out like a delicate lace veil across the vastness of space. Composed mostly of water ice, the rings glitter brilliantly in sunlight, shimmering with shades of silver, pearl, and soft gold. Some particles are no bigger than grains of sand, while others rival the size of mountains. The rings are divided into 7 main groups, labeled A, B, C, and so forth, with countless smaller divisions between them. Gaps like the famous Cassini division separate these groups, created by the gravitational dance of Saturn's moons, a silent, choreographed whisper in the cosmic ballet. But these rings are not eternal. Geologically speaking, they are quite young, perhaps only 100 to 200 million years old, and slowly the icy particles drift inward, falling into Saturn's atmosphere. The grand celestial performance will one day end. But for now, dear dreamer, the show goes on. Saturn does not spin alone. It reigns over a court of more than 140 moons, icy wanderers, rocky misfits, and some of the most fascinating worlds in our solar system. Let us meet a few. Titan, the largest of them all, even bigger than Mercury, is wrapped in a thick golden atmosphere rich in nitrogen. Here, rivers flow, lakes shimmer, and rain falls, but not of water. Instead, liquid methane fills its alien seas. Scientists believe a hidden ocean of liquid water lies beneath Titan's crust, making it a world of shadowy orange skies and mysterious seas, a moon that might harbor life. Enceladus, a bright icy moon, bursts with geysers that shoot water vapor and organic molecules into space. Beneath its frozen shell lies a global ocean, warmed by tidal forces tugging gently beneath the surface. Enceladus is one of the best places beyond Earth to look for life. NASA's Cassini spacecraft even flew through its plumes, tasting the material that whispers, "Come closer." Other moons, Mimas, Tethys, Rhea, Dione, each tell their own stories with unique landscapes. Craters like empty eyes, icy canyons, and even tiny rings formed from their own debris. These moons do more than orbit. They sculpt Saturn's rings, shape its magnetic field, and interact in a delicate cosmic dance. Saturn's system is like a miniature solar system, a symphony of balance and motion. Humans have gazed at Saturn for centuries. Galileo first spotted its rings in 1610, though he could not understand what he saw. Later, Astronomers like Christian Huygens and Giovanni Cassini unraveled many secrets: moons, ring gaps, mysterious motions. In recent times, Saturn was visited by the Voyager probes and orbited by the Cassini spacecraft, which studied the planet for over 13 years. Cassini revealed storms shaped like roses, sunlight sparkling off Titan's lakes, and shadows sweeping across the rings. The mission ended in 2017 with a poetic finale, diving into Saturn's atmosphere while sending back precious data until the very last moment. A final waltz with the Queen of Elegance. Saturn is not loud, violent, or boastful, but it is endlessly beautiful. It reminds us that elegance is a form of strength, that silence can hold great power, and that time leaves its mark not only in craters, but in the slow pull of gravity, the drip of ice, and the dance of moons. Its rings are fading, its storms have quieted, yet its grace lingers. Perhaps this is the lesson. Everything changes, everything passes, but true beauty leaves echoes across the sky. So sleep now, dear dreamer. Let Saturn's rings spin in your imagination. Let Titan's golden haze lull you to rest. Drift on Enceladus's icy geysers and dream of dancing with a planet that glides through the darkness with dignity and light. Far beyond the glowing rings of Saturn, in the dim twilight where stars seem to hang closer than the light itself, lies Uranus, a planet both quiet and peculiar. It does not boast the grand storms of Jupiter, nor the dazzling spectacle of Saturn's rings. There are no fiery volcanoes erupting, no swirling tempests shouting for attention. Instead, Uranus holds a subtle beauty, calm and elegant, often overlooked. It tilts gently on its side, as if lost in deep thought. Its surface glows softly in shades of aquamarine, inviting only the most patient dreamers to unravel its mysteries. Drift with me now, dear dreamer, into the frozen grace of Uranus. Uranus is the seventh planet from the Sun, and it was the very first to be discovered using a telescope. Unlike the planets known to ancient sky watchers, Uranus remained hidden in plain sight, unnoticed until the year 1781. It was then that the astronomer William Herschel spotted a faint star moving too slowly for its kind. He had accidentally uncovered a new world. What a remarkable planet it is! With a diameter of about 51,000 kilometers, Uranus is the third largest planet in our solar system. Like Jupiter and Saturn, it is a gas giant, but with an unusual twist. It belongs to a group called the ice giants. This is because, deep inside, it contains more frozen substances such as water, ammonia, and methane. Its atmosphere is mostly hydrogen and helium, but it's the methane that paints the planet in its dreamy blue-green hue. Methane absorbs the red light and reflects blue, giving Uranus a soft, otherworldly glow, like moonlight shimmering on a glacier. Yet the most astonishing feature of Uranus is its tilt. Unlike any other planet, it spins almost completely on its side, with an axial tilt of about 98 degrees. Imagine rolling a ball across the floor, not spinning it upright but sideways. This is how Uranus moves. It doesn't twirl in the usual way, it lounges. Because of this strange tilt, Uranus experiences seasons unlike any other. Each pole bathes in 42 years of continuous sunlight, followed by 42 years of darkness. A summer of endless day, then a winter of unbroken night. The rhythm of Uranus is slow, strange, and quietly poetic. At first glance, Uranus seems serene and almost featureless. But if you look closer, dear dreamer, you will discover storms hidden beneath its pale atmosphere. Winds can roar at speeds over 900 kilometers per hour, unseen but powerful. Dark spots and swirling vortices have been glimpsed, moving silently across the planet's face like gentle ghosts. Unlike Jupiter's bold stripes or Saturn's shimmering rings, Uranus keeps its drama cloaked in whispers of icy calm. Beneath the clouds, scientists believe there lies a strange, slushy ocean made of water, ammonia, and methane, resting above a rocky core. This exotic mantle may even create storms of diamond rain. Yes, you heard that right. Deep within Uranus, the immense pressure might turn carbon atoms into sparkling diamonds, raining jewels through layers of ice. Imagine diamonds falling through a frozen sea, nature's own treasure lost in the dark. Though not as flamboyant as Saturn, Uranus does have rings, 13 known rings to be exact. These rings are dark, narrow, and faint, discovered only in 1977 when they briefly blocked starlight during a rare event. Made of dark particles coated with carbon-rich material, these rings orbit in perfect, ghostly alignment with Uranus's tilted axis. The inner rings are tight and thin, while the outer ones spread wider, whispering rather than singing, a shadowy crown worn by the silent king of the ice giants. Uranus is also home to at least 28 moons, each named after characters from Shakespeare's plays and Alexander Pope's poems. There is Titania, queen of the fairies, and Oberon, her noble king. Miranda is scarred and strange, with cliffs towering taller than any found on Earth. Ariel and Umbriel, frozen and cratered, circle the planet like quiet storytellers. Miranda's surface, in particular, tells a haunting tale, perhaps shattered by ancient impacts and pieced back together, or shaped by some icy drama frozen in time. These moons do not shout. They murmur stories of ancient collisions and hidden oceans, orbiting in quiet harmony around a planet forever lost in thought. So far, Uranus has been visited only once, by the Voyager 2 spacecraft in 1986. It flew by quickly, snapping photographs, measuring magnetic fields, and capturing the silent dance of a planet spinning sideways. No orbiter has yet returned to explore Uranus in more detail. And so Uranus waits, quiet, distant, and unbothered. Interest in this mysterious world is growing. New missions are being planned to study its rings, interior, storms, and moons. Scientists believe Uranus may hold the key to understanding not only our solar system, but many others. Ice giants like Uranus seem common in distant galaxies, and unraveling its secrets could help us unlock the mysteries of alien worlds. For now, Uranus remains a sapphire loner, a tilt in time, a whisper in the frozen void. So rest now, dear dreamer. Let Uranus's quiet elegance surround your thoughts. Float beneath its turquoise skies, drift beside its Shakespearean moons, and remember, not all wonders shout. Some simply tilt, glow, and patiently wait to be seen. Far beyond the warm glow of the sun lies Neptune, the farthest known planet in our solar system. Here, darkness rules, where the sun is nothing more than a tiny, distant star, barely lighting the endless night. Winds howl across thick, icy clouds with speeds faster than anything else in the cosmos. This is Neptune, the eighth planet, the silent guardian of the deep, a mysterious blue jewel spinning in the void. Named after the Roman god of the sea, Neptune truly wears her name with pride. She is fluid and deep, wrapped in a calm coldness that hides her restless soul. Imagine drifting with me into her shimmering shadow, where silence and power dance in perfect harmony. Neptune was the very first planet found not by looking through a telescope, but by the power of mathematics and pure curiosity. In the early 1800s, astronomers noticed something strange. The orbit of Uranus was not behaving as expected. It wobbled, pulled by an invisible hand. Great minds like Urbain Le Verrier in France and John Couch Adams in England worked separately, but came to the same conclusion. Another planet must be out there, tugging on Uranus from the darkness. And when telescopes finally aimed at the predicted spot in 1846, Neptune revealed herself, like a secret finally uncovered. With a diameter close to 50,000 kilometers, Neptune ranks as the fourth largest planet. Like its neighbor Uranus, it belongs to a special family called ice giants. Its atmosphere is a swirling mixture of hydrogen, helium, water, ammonia, and methane. It's the methane that gives Neptune her deep, brilliant blue, richer, and more intense than Uranus, like a planet made of crushed sapphires under a midnight sky. But behind that stunning beauty hides chaos. Neptune is home to the fastest winds in the solar system, rushing at speeds up to 2,100 kilometers per hour, faster than the speed of sound on Earth. Imagine storms so fierce they could tear apart steel, spinning endlessly in a world colder than any place on our planet. In 1989, NASA's Voyager 2 became the only spacecraft to visit Neptune up close. It discovered the Great Dark Spot, a giant storm as large as Earth itself. This dark hurricane was a fierce bruise on Neptune's atmosphere. When Voyager's cameras returned years later, the storm had vanished, replaced by new tempests. Neptune does not hold on tightly to her storms. She lets them come and go, always changing, always alive. Her sky is never still. Winds roar, clouds form and disappear, and the planet's atmosphere churns in endless motion. Beneath Neptune's blue clouds lies a strange, slushy ocean, an exotic mixture of water, ammonia, and methane, crushed under immense pressure. Deeper still, there may be a rocky core, surrounded by rains of diamonds falling through the sky, just like her cousin Uranus. Despite being over 4,500,000,000 kilometers away from the Sun, Neptune shines with its own heat, glowing with a secret warmth that puzzles scientists. Is it leftover heat from when the planet formed, or a slow contraction of its mass, generating energy deep inside? Even here, far from the Sun's gentle touch, Neptune holds a quiet fire beneath her icy veil. Neptune wears a faint halo of rings, 5 main bands made of dark, dusty particles, thin and fragile like smoke caught in a beam of light. These rings are hard to see but real, like delicate threads woven into the night. Then there is Triton, Neptune's largest moon and one of the most intriguing worlds in the solar system. Triton is frozen solid, with icy geysers that shoot nitrogen fountains into the air, falling back in shimmering arcs. Its surface is a strange patchwork of ridges, flat plains, and peculiar cantaloupe terrain. What makes Triton even more mysterious is its backward orbit, spinning the opposite way around Neptune, a clue that it was once a wanderer, captured by Neptune's gravity, a cosmic refugee. Beneath its frozen crust, Triton may hide a liquid ocean where life might still exist, waiting quietly beneath the ice. Neptune marks the edge of what we know. Beyond her lies the Kuiper Belt, a vast field of icy worlds like Pluto, Eris, and Haumea, silent sentinels in the dark. Beyond that, the great unknown. But Neptune is not just an ending. She is a gateway, a bridge between the familiar and the mysterious. She shows us that even in the coldest, darkest corners of space, there is movement, beauty, and power. She reminds us that the universe still sings its quiet song far from the sun's warmth. Voyager 2 passed by Neptune, taking photos, measuring storms, then journeyed onward into the stars. No spacecraft has returned since, but one day we will come back, and Neptune will be there, spinning slowly in her endless dance, wrapped in blue, watching the distant stars like a dreamer herself. So now, dear dreamer, rest. Let Neptune's winds carry your thoughts. Let Triton's icy geysers mist your dreams. And let the silence of the outer solar system remind you that even the coldest places hold warmth, wonder, and life's eternal motion. Now we leave behind the giant planets, their swirling storms and shining rings, and journey into the silent, cold outskirts of our solar system, the realm beyond the Kuiper Belt. Here, the sun is no more than a faint glimmer, a distant spark in an endless sea of darkness. Floating in this frozen deep is a tiny world once celebrated as the 9th planet. A small, icy sphere wrapped in shadow and mystery. It's so small it could fit inside the United States, yet it captured the hearts and minds of millions. This is Pluto. Though it no longer holds the official title of planet, Pluto remains a powerful symbol, a beacon of wonder, resilience, and the ever-changing nature of science. Together, let us tell its story with warmth, respect, and just a hint of rebellion. In the early 1900s, astronomers noticed strange wobbles in the orbits of Neptune and Uranus. They suspected another, unseen planet, Planet X, was pulling on them with its invisible gravity. Then came Clyde Tombaugh, a young farm boy turned astronomer who spent endless hours peering at photographic plates at an observatory in Arizona. In 1930, after tireless searching, he spotted it, a tiny dot moving slowly against the starry backdrop. Pluto had been found. The name came from an 11-year-old British girl named Venetia Burney, who suggested Pluto, after the Roman god of the underworld, a perfect fit for this dark, distant world. It honored myth, mystery, and shadow. For decades, Pluto proudly held its place as the ninth planet. Small, yes, only about 2,400 kilometers across, smaller than our moon, but mighty in personality. It has a heart, a literal one, a vast, bright glacier shaped like a heart called Tombo Regio, made of shimmering nitrogen ice. This heart pulses with Pluto's soul. In 2015, NASA's New Horizons spacecraft flew past Pluto, giving us our first close-up look. What we saw was breathtaking. Towering mountains made of water ice, smooth plains without a single crater, telling us Pluto is still geologically active. We saw blue skies, hazy layers of atmosphere, and signs of cryovolcanoes, volcanoes that erupt ice instead of lava. For such a small world, Pluto is alive with stories. But Pluto doesn't travel alone. It has 5 known moons. The largest, Charon, is nearly half Pluto's size, so close and so big that they orbit a point outside Pluto's surface, creating a cosmic duet, a binary system. Charon's surface is marked by deep chasms and cliffs, evidence of an active past. It even has a strange red stain near its pole, possibly made of organic molecules, its own quiet mystery. The other smaller moons, Styx, Nix, Kerberos, and Hydra, spin like icy dancers around their distant parent, each named after figures from the underworld. Together, they form a family, odd and asymmetrical, yet full of rhythm and harmony. Then, in 2006, Pluto's story took a turn. As astronomers explored the Kuiper Belt more closely, they found many small, icy worlds, some nearly the size of Pluto, like Eris, Makemake, and Haumea. Suddenly, Pluto was no longer unique. Astronomers had to rethink. Which of these bodies deserved the title planet? The International Astronomical Union stepped in with a new definition. A planet must orbit the Sun, be round due to its own gravity, and have cleared its orbit of other debris. Pluto met the first two, but not the third. It shares its neighborhood with countless icy cousins. So, Pluto was reclassified as a dwarf planet. The internet erupted with grief. Children wrote angry letters. Adults gasped in disbelief. A whole generation felt as if their childhood planet had been taken away. But science wasn't erasing Pluto, it was refining how we understand the universe. Pluto didn't shrink, our knowledge simply grew. Today, Pluto drifts in the heart of the Kuiper Belt, a frozen realm of leftover building blocks from the solar system's birth. It's a relic, a survivor, a messenger from the past. New Horizons revealed not just a cold rock, but a poetic world, alive with weather, shifting ice, and mysterious internal heat. A world that may still hold secrets deep within its frozen core. Though it no longer carries the label planet, Pluto has gained something deeper: affection, mystery, and a lasting legacy. It teaches us that names may change, but wonder never fades. That size does not measure importance. That even the smallest worlds can capture our biggest dreams. So rest now, dear dreamer. Let Pluto cradle you in its icy arms. Let its quiet heart beat softly beside your own. Drift with Charon. Dance through the distant dark. And remember, sometimes being different is the most beautiful thing of all. black holes silent thieves of both light and time. Now, we leave behind the familiar glow of stars and planets, drifting beyond the shining, the spinning, the known. Out here in the deepest, darkest corners of the cosmos lie the greatest mysteries. These regions are so dense and powerful that not even light can escape their grasp. But they are not monsters, nor simply empty voids. They are echoes of stars long gone, scars left behind by catastrophic collapse, and guardians of cosmic secrets. They are black holes. Come closer now, dear dreamer. There's no need to fear. Though black holes swallow light itself, they can illuminate the soul. To truly understand a black hole, we must first meet a dying star. Massive stars, those much larger than our sun, spend their lives fusing hydrogen into helium. Then, as they age, they fuse heavier elements like carbon and oxygen, pushing their cores to extremes until they build up iron. Iron, unlike lighter elements, cannot release energy through fusion, so the star begins to falter. Gravity, always waiting in the wings, seizes control. Suddenly, the star collapses inward, violently and without mercy. Its outer layers explode in a brilliant supernova, lighting up the galaxy with a spectacular cosmic firework. But the core keeps falling inward, compressing and crushing itself. If the star is massive enough, this collapse does not stop. The core is squeezed so tightly that it forms a singularity, a point of infinite density where the laws of physics as we know them break down. Around this singularity, space itself folds inward, creating a boundary called the event horizon. Once anything crosses this boundary, there is no return. A black hole is born not from chaos, but from surrender. Black holes come in many sizes. Stellar black holes, formed from collapsing stars, are only a few kilometers wide, but can contain more mass than several suns combined. Intermediate black holes may form when stars cluster and merge, still elusive and mysterious to astronomers. Then there are the supermassive black holes, millions or even billions of times the mass of our sun. These giants lurk at the centers of galaxies, including our own Milky Way. Our galaxy hosts a supermassive black hole named Sagittarius A star, over 4 million times the mass of our sun. It hides behind thick clouds of dust, slowly feeding on stars and gas. But here's an important fact. Black holes don't suck like cosmic vacuum cleaners. They don't roam the universe devouring everything in their path. If our sun were suddenly replaced by a black hole of the same mass, Earth would continue orbiting just as before, cold, yes, but untouched in its path. Black holes only affect objects that come too close. The event horizon marks the point of no return. Cross it, and nothing escapes, not ships, not signals, not even light itself. To a distant observer, time seems to slow dramatically for anything approaching this boundary. A spaceship nearing the event horizon would appear to freeze, inching closer, but never quite reaching the edge. Its signals would stretch into red oblivion, fading away like a sigh whispered backward. But to the traveler aboard, time feels normal until it doesn't. As they cross the horizon, there is no stopping or turning back. Space becomes warped. Time becomes tangled. Inside lies the singularity, the point where density becomes infinite and gravity pulls inward through dimensions beyond our understanding. What happens there? No one knows. Our current physics breaks down. Perhaps reality itself does too. But black holes do more than just take. They give back in unexpected ways. Around many black holes, matter swirls in glowing disks called accretion disks, heated to millions of degrees as it spirals inward. These disks emit powerful X-rays and radiation that can outshine entire galaxies. Sometimes, jets of plasma burst from the poles at nearly the speed of light, launched by twisted magnetic fields. These jets stretch for thousands of light years, painting space with the fingerprints of the invisible. Thanks to brilliant minds like Stephen Hawking, we know black holes may not be eternal. Hawking proposed that they emit tiny amounts of energy over time, now called Hawking radiation. Slowly and subtly, they may evaporate, losing mass and eventually disappearing. Even black holes, it seems, cannot escape the cosmic cycle of birth and death. For centuries, black holes were just theoretical shadows, feared, doubted, imagined. Then, in 2019, the Event Horizon Telescope gave us the first ever image of a black hole's shadow. A glowing ring surrounding darkness in the galaxy Messier 87. That image wasn't just a scientific breakthrough. It was a poem made of photons, capturing the silhouette of a cosmic phantom. And we are not done yet. New observations, new telescopes, new minds are working tirelessly to unravel these mysteries. Black holes have become tools and probes to test gravity, quantum theory, and even the nature of time itself. They may one day unlock answers about the beginning of everything and what lies beyond the end. So rest now, dear dreamer. Let the pull of the cosmos rock you to sleep. Black holes will remain silent, patient, swirling in the dark. They do not need light to shine. They shine instead in questions: the Big Bang, the first whisper of creation, and the endless mysteries of the universe. Everything you see and know, the stars, the planets, even the vast emptiness between them, once all existed as a single, unimaginably tiny point. Imagine no space, no time, just endless possibility compressed into a speck smaller than an atom. This was the universe before the Big Bang, a moment before moments, before light, before time itself began to tick. About 13,800,000,000 years ago, everything changed. Not by exploding into space, but by creating space itself. The universe expanded faster than anything we can imagine. In less than a trillionth of a second, it grew from that tiny speck to the size of a galaxy. Light came into being. Time started flowing. Particles began to move and mingle, setting the stage for everything that would follow. The newborn universe was blisteringly hot, an intense cosmic soup swirling with particles like quarks, gluons, photons, and electrons, all locked in a chaotic, beautiful dance. But as the universe expanded, it began to cool. Slowly, quarks paired up to form protons and neutrons. After just a few minutes, these came together to create the simplest atomic nuclei: hydrogen, helium, and traces of lithium. Atoms couldn't form yet. They were still too hot, but the building blocks were ready. For nearly 400,000 years, the universe remained a dark place, too hot and dense for light to travel freely. Then, at last, it cooled enough for atoms to settle, and light escaped for the first time. This ancient glow, called the cosmic microwave background, still washes across the sky today. The oldest light we can ever see, a whisper from the dawn of everything. After that quiet cosmic night, gravity began its subtle work, gathering matter into tiny clumps. These ripples grew into clouds of hydrogen gas, which collapsed into stars. The first stars burned fast and bright, massive and blue-white. They lived hard and died spectacularly, exploding as supernovae that forged heavier elements: carbon, oxygen, iron, and even gold. From these cosmic fireworks, galaxies began to form, billions of them, each holding billions of stars. Among these stars, in one quiet spiral arm of one galaxy, a small yellow star was born. Around it, rocky planets formed. On one of them, life began, a miracle of chemistry and chance that led to you, here and now, hearing this story. Since that first heartbeat of the cosmos, the universe has never stopped growing. Space itself stretches and expands, galaxies drift farther apart. The stars continue their ancient dance, and you are made of the same stardust. The hydrogen in your body is over 13 billion years old. The calcium in your bones was born inside dying stars, and the iron in your blood was forged in cosmic fire. You are not merely in the universe, you are of it, a living echo of the Big Bang, the cosmos reflecting on itself through you. What lies ahead? The universe may keep expanding forever, growing colder and darker, or gravity might one day slow and reverse this journey. Dark energy, a mysterious force we barely understand, could speed it toward endless isolation. We don't know the ending yet, but the story goes on. Every supernova, every planet, every beam of light is part of this grand unfolding narrative. And you, dear dreamer, are part of it too. So rest now. The stars, older than time itself, still burn for you. Let the echo of that first light cradle your dreams, and remember, from emptiness, everything came to be.